Alright guys, here's Unit 3, Objective 3.2, Verifying Trig Identities. The main idea here for Objective 2 is to only work on one side of the equation, okay? So please put that in your mind. Students sometimes they think they don't know, because they don't know what they're doing. They think, oh, if I divide both sides by something, I can make it work. You cannot change both sides of the equation, okay? It's just going to make it more difficult for you to solve. It's going to make it even, you're going to be changing both sides. You won't be able to come up with something that are equal each other. So if you could put something in your head, is to stop changing both sides of the equation. You pick the side that is most difficult for you and you leave the other side alone, okay? Maybe you want to work on only the left side. Work on the left side and then you make it equal the right side, all right? So you leave the right side alone. Sometimes the right side is the side that you want to work on. It depends. You will see as you practice this that you only need to work on one side of the equation to make it look like the other, all right? Don't ever, the moment you start, oh, I want to subtract to this side, you already start it wrong, okay? The moment you try to do things to both sides, that's already wrong, all right? So please put that in your head. Let's do a few examples, and then we'll do some of your homework together, and then we'll go from there, okay? All right, so let's take a look at over here. My very first example is the secant square of theta minus 1 over secant square of theta equals the sine square of theta. So when I look at this, I'm trying to decide which side is the best side to work on. So definitely the sine square of theta, I can switch this for one of the quotient identities. I know that is just 1 over cosecant square of theta. But that doesn't help me. So definitely you have to agree with me that this left side is more difficult. So I'm going to mess with the left side, see if I'm successful to make it look like the right side. So I'm definitely going to leave this side alone. I'm going to put a barrier right here. I am going to leave that side alone. I'm not going to mess with that side. But then if you have your trig identities card right next to you, you immediately is going to start noticing, I know what this is. The secant square of theta minus 1 is the tangent square of theta. So immediately you should know and recognize, I got it. I know how to substitute this guy right here immediately, okay? I can substitute that. So I'm going to substitute that for the tangent square of theta, because that's what that whole thing equals. All over, I can also go ahead and substitute this right here. I know what that is. I know that the secant square of theta is just 1 over the cosine square of theta. So I'm going to substitute that as well. So 1 over cosine square of theta. So there we go. We did 2 substitution. When we did these 2 substitutions, we created a complex fraction. It's something that we saw in worksheet 0. So I know I can do my famous Kentucky chicken fried here. I'm going to keep this. I'm going to change to multiplication, and I'm going to flip this fraction. Okay, so let's go ahead and do that. I'm going to keep it as tangent square of theta times, and I'm going to switch this, I'm going to flip it. It's going to be cosine square of theta all over 1. And that didn't quite help us unless we change the tangent square of theta to something we know about. Okay, I know that the tangent square of theta is the sine square of theta all over the cosine square of theta times the cosine square of theta all over 1. So there we go. I have my eye on the ball here. I know I'm supposed to end up with the sine square of theta. I know this 2 right here, when I multiply, reduces to 1. And there you go. I have my sine square of theta all over 1, which is just simply equals the sine square of theta, and I'm done. Okay, so I know I was, please forget this right here. Okay, so I was able to make them equal only picking one side and substituting in for things that I recognize, okay? So as you can see, substituting for trig identities, using algebra, okay? Algebra is always involved with our substitutions, so we can get to one side to equal the other. Notice, I never mess with the side over here, okay? So let's practice one more time. I have various examples here for you. Now, you will see these examples, the ideas, the techniques I used here. You'll see it on your homework. So please keep these notes organized the way I have it here with my information. I use, keep, change, flip. I substituted for trig identities. Okay? All right, let's try another example. Take a look at over here. Holy guacamole. Is it hard? Heck yeah, it's hard. Okay? All right, so let's take a look. You have to agree with me that these fractions are way harder than this expression right here. Okay? So I am going to go ahead and pick the right-hand side to work on. The left-hand side, I can substitute it. Okay? I can even write with pencil if you want, really work on both sides. You can say, well, this is just 2 times 1 over cosine square of alpha, but how did that help me? It really didn't. I can leave it there because they're equivalent, but that didn't help me at all. Okay, so as you can see, picking the right side here, it's the most difficult side. So you can leave that there. Let's see if that's going to help us or not. Okay, I'm going to come back over here and work on the right-hand side. Immediately I see, what do we have here that we talked about before? I have the same exact 1 and the sine of alpha, but I have different operation. That is the conjugate. Okay, I immediately recognize conjugates. Right? And I know conjugates because we worked on it before. Most famous conjugates are differences of squares. Okay, so I know that if I multiply top and bottom over this side by 1 minus the sine of alpha, and here 1 minus the sine of alpha, okay? And on this other side, I'll multiply by the conjugate, 1 plus sine of alpha, and over here, I cannot fit it, but it's 1 plus the sine of alpha, okay? I'm multiplying both sides by the conjugates. Okay, so over here in the numerator, 1 times 1 plus sine of alpha will be 1 plus sine of alpha all over the conjugates together. What happens when I multiply 1 plus the sine of alpha times 1 minus the sine of alpha? What happens? Okay, these are difference of squares. We get 1 minus the sine square of alpha. Okay, that's my little work reminding me what conjugates give me. So I know my denominator is 1 minus sine squared of alpha. Okay, plus on this side, I have 1 times 1 minus sine of alpha all over the multiplication of the conjugate, which is 1 minus sine squared of alpha. Now I have common denominators. When I have common denominators, I may add fractions. Okay, because I have common denominator, because we have common denominator. Okay, because I have common denominator, I can definitely add up my fractions. So I'm going to add into one fraction with the same exact denominator of 1 minus sine squared of alpha. So let me see, 1 plus 1 is 2, but this positive sine of alpha plus this negative sine of alpha is going to be gone. They add up to 0. So there we go. We have 2 over 1 minus sine squared. How did that help me? Okay, I no longer have 2 fractions, I only have 1 fraction. Then I recognize, I stare at my identity flashcard until I say, I know what this is right here. I know that that is, by the identity, that is the cosine squared of alpha. So I have 2 all over cosine squared of alpha. If I split this into 2, taking this 2 out over here in the front, I'll have 2 times 1 over cosine squared of alpha, which is exactly what we saw happening up there. 2 times 1 over cosine squared alpha. So this is 2 times the secant squared of alpha, which does equal this other side over here that we were already staring at it. It worked, okay? So as you can see, conjugates will show up all the time, and then conjugates gives us the same common denominator, so we can add or subtract fractions. In this case was adding, combining like terms, and then boom, shakalaka. All right? So what did we learn from this one? Conjugates, okay? Conjugates helps us make common denominators, all right? Okay, let's take a look at another one. Slowly, one at a time. Okay, here's another holy guacamole, hard problem. They're all hard, okay? So you have to agree with me that in this case, the left side looks way more complicated than the right side. So I'm going to pick the left side to work on. Sometimes things look way uglier than what really is, but let's just go slowly, okay? Take a look at your flashcard, take a look at your identities, okay? Stare at it for a minute, see if you recognize any items that can be replaced, okay? Immediately, you should recognize this guy right here, okay? Immediately. If you have your flashcard in front of you, you should say, I can substitute that for the secant squared of x. I'm going to do that. The secant squared of x times, okay? And then I look at this guy in my flashcard, look over and over and over, and I say, there's really nothing I can replace it, except I do know that the cosine square of x can be replaced with something. I have to leave the -1 alone, but I know that that can be replaced with something. And that is the 1 minus the sine squared of x. Okay? All right, not too bad. We did, at least we substituted 2 things now, right? So let's go ahead and see what we can simplify or combine like terms. This -1 right here and this +1 right here. Definitely I can simplify that, right? So 1 minus 1 is 0. Now I have the secant squared of x times the negative sine squared of x. Okay? All right, so I want to end up with tangent. I know here I'm going to just write myself a note. Okay, I'm not messing on both sides, but I'm going to write myself a note. I know that the tangent squared of x is the sine squared of x all over the cosine squared of x. I know that. So I need to somehow make that over here appear to help me out to come up to a tangent. So I'm going to go ahead and replace the secant squared of x with something that I can use. Okay, I can definitely turn that into 1 over cosine squared of x times, I still have my -1 and the sine squared of x. Okay, it's starting to look nice. Okay, I'm starting to see a light at the end of the tunnel because I'm like, okay, sine and cosine, there it is. My tangent should start appearing here really quick. If I see this as over 1 and there's a multiplication here, I can just multiply my numerators and my denominators. 1 times the negative sign, so I get a negative sine squared of x all over 1 times my cosine is cosine squared of x. So there we go. I see it. They do equal. This is nothing but negative, and this is the tangent squared of x. Okay, and there's the negative, okay, that survived from this negative over here. It does equal my negative tangent squared of x. Therefore, I was successful. Okay, so all we used here was substitution of trig identities. Okay, so let that soak in your mind for a little bit. How I substituted this whole item over here, and then I substituted just that little piece of that parenthesis, and start cleaning up. Okay, again, I was not messing on both sides. I was just putting my idea of what I want to get to. Okay. All right, let's do one more example and then we'll go to your homework, okay? These problems are all different. They're like snowflakes. They're never one that are exactly the same like the other. Never. They're all different. I could do 30 of them here for you, and then you're going to look at your homework and say, she didn't do any of these like my homework. It's because every single one of them are different. The idea is the same. I need to always be looking at my identities and use some algebra. Okay? Let's take a look at the next example. All right. You must agree with me that both of these sides are hard. It's kind of like, which side do I pick? They're both difficult to work with. But I like tangent because I can switch tangent. I like cotangent. I can switch that, okay, to something I know. So, and I can switch this too as well, but you know, it really doesn't matter which side you want to work on. I preferably will always pick tangent and cotangent over the other functions to work with. So I am going to pick my left-hand side for this case, okay? Hopefully using tangent and cotangent with sine and cosines is always the first thing I want to go. I always run to sines and cosines. That's always I run to. If I can turn things into sine and cosines, I will get somewhere, okay? Remember, I have an addition of two things. So be careful with addition. If we want to add fractions, add or subtract fractions, we're going to need common denominator. So see, the algebra skills keeps coming back. Because why am I talking about fractions and common denominators? Because I know that tangent is a fraction, okay? So here we go. I am going to switch the tangent for the sine of x over the cosine of x. And the cotangent, I have this addition, I can switch it for the cosine of x all over the sine of x. They're opposite fractions. They're opposite reciprocals, right? They're reciprocals of each other. They're opposite. So I have an addition of fractions. That's exactly what I knew in my mind here. I need to have common denominators. I cannot add this together unless I multiply both of them to make a common denominator. This side, I'm going to multiply by the cosine. But on this side, I'm going to multiply by the sine of x. Okay? So we can have common denominators. All right? So when I multiply sine of x times sine of x, we get sine squared of x all over the denominator of sine of x times cosine of x. Plus, on this side, we get cosine squared of x, because cosine of x times cosine of x is cosine squared of x. But then we have the same exact denominator of sine of x times cosine of x. So there we go. That's exactly what I had in mind right here. If I'm adding or subtracting fractions, I must have common denominator. So successfully I got that. Then since I have common denominators, now I can add into one fraction my numerator. I have the sine squared of x plus the cosine squared of x all over the common denominator of sine of x times cosine of x. Now let's see what we can do. Immediately you should recognize this guy right here. It's our Pythagorean identity. Okay? So I can replace this whole thing with number 1. 1 over the sine of x times the cosine of x. Nice. Everything in terms of sine and cosine. Because I have a multiplication and the numerator of 1, and I want to turn into something, I know secant is 1 over cosine, cosecant is 1 over the sine. I can do that. I can make that appear right here. I'm going to split into two fractions, okay? I'm going to say 1 over the sine of x times 1 over cosine of x. These two are completely equivalent, all right? These together or separate is an equivalent expression. So there we go. I know that 1 over sine is our cosecant of x times, and 1 over the cosine is our secant of x, which equals exactly secant of x times cosecant of x. Therefore, we were successful. Again, was algebra and substitution. Okay? We never messed with this other side. All right? So I hope by these last 4 examples you notice that all I do is I stare at my identity cards and I use some sort of algebra skills that we've been talking about. Okay? No problems are ever alike. Okay? No 2 problems are ever alike. So let's go ahead back to your worksheet. So what do I want you to do today? For the rest of the class period, I want you to focus on your worksheet 2. Okay? Let's grab your worksheet 2. I'm going to do 2 problems for you. I picked the hardest ones, and I left you with the easiest ones. Okay, 1 through 5 is easy, and then 6 should blow your mind, which I'm going to do it here. And then the other ones are kind of start getting a little bit more difficult, but it's doable. Okay, so let's go ahead and see what we got here. So let's go to number 6. It's from your homework. Worksheet 2. All right, you have to agree with me that you have this binomial inside of this parenthesis that I'm squaring it. I think of algebra. Okay, you always got to look at trig identities and say, what kind of algebra do I have here? Okay, so I think of x plus y squared. Okay, let me even write that, what I'm thinking on the side over here. I am thinking for some reason if I had x plus y squared, okay, an item plus another item squared, and they're completely different from each other. How would I approach this in terms of algebra? Well, I would FOIL it, because being squared is the same thing as x plus y times x plus y. Okay, and how I would change this, I would FOIL it. Okay. I've been doing foiling for so many years that I know that this becomes squaring the first item, which is x squared, multiplying them together, 2 times x times y, which is 2xy, and then you square the last, plus y squared. You should never, at this level of math, be doing foiling anymore. You should be able to look at a binomial squared and go straight to the trinomial part of it. So when I look at this, I say, I am going to mess with it using my algebra skills. I'm going to leave the right side alone, and I'm going to mess with the left side. Okay? So I'm going to use this algebra skills of foiling this binomial over here. I'm going to square the first item, is going to be tangent squared of alpha. And then I'm going to multiply 2 times the tangent times the cotangent of alpha. So plus 2 times the tangent of alpha times the cotangent of alpha. And then I'm going to plus square the last term, cotangent squared of alpha. So that's exactly what I did with the algebra with x and y's. I did with trig function. Okay, now I'm ready to start substituting for whatever I can recognize. Okay, I recognize that this right here, tangent squared, can be substituted for something. I recognize that the tangent of alpha can be substituted. The cotangent of alpha can also be replaced, substituted, and the cotangent square of alpha. All these things, we can change it for something else. Okay? So the tangent squared of alpha is the secant squared of alpha minus 1. That's what I substituted for the tangent squared of alpha. And then I have this plus 2. I'm going to put a parenthesis because I'm going to bring in the fraction equivalent of tangent. Tangent is sine of alpha over cosine of alpha. And it's multiplying the cotangent, so I'm going to open another parenthesis for that cotangent, which is the reciprocal, cosine of alpha all over sine of alpha. Plus, and then what can I substitute for the cotangent squared of alpha? We can substitute it with cosecant squared of alpha minus 1. So I did a bunch of substitution after I used my algebra skills. Let's see what simplifies here. Okay, let me use a different pen here so you can see. Wait, the cosine times the cosine, and the sine times the sine here all simplifies to a number 1. Okay? So I'm going to write this as secant squared of alpha minus 1 plus 2 times this becomes times a 1. Okay? Because the sine cancels with the cosine and all that becomes a 1. And then I continue with my plus cosecant squared of alpha minus 1. Now let's see if I can combine like terms here. Okay? I have this negative 1 right here and this negative 1 right here. So I'm going to have the secant squared of alpha minus a 2 because I'm combining the negative 1 with the negative 1 to become the negative 2. Okay, I'm just combining the negative 1s. But I still have this plus 1 right here, plus 2 right there. And then I still have my plus cosecant squared of alpha. Okay, so all I did was combine my negative 1s to give me my negative 2. And then I can see that this negative 2 and this positive 2 goes away, adds up to a 0. So now I have the secant squared of alpha plus the cosecant squared of alpha, which is exactly what we have over here on this right-hand side. Okay? So what do we used? Algebra, and then substitutions, and then starting combining like terms. Okay? Algebra, always substitution, and combining like terms. All right? So that was number 6. It looks hideous, and we made it look less hideous. Okay? All right, now let's take a look at one last example from your homework, and then you have the rest of the class time to do the problems on your worksheet 12 that I'm assigning. Okay? One more here. Problem number 10. All right, so I have secant square of beta plus tangent square of beta times secant square of beta. All this ugly, hideous thing got to equal secant to the 4th power of beta. So I'm definitely going to pick the longer, more complicated side. What do I see here if I substitute it with other variables? M. Okay, I would see an m squared plus, I can also substitute that for m, so let's put an x. And then here's my x squared, right? And then the secant squared, let me put it as, because I already substituted for an m, has to be m squared. So when you look at this in terms of algebra, I have an addition and I have 2 terms. What can we factor out? We can definitely factor out the GCF, which is the m squared, and then we put the leftovers in here of 1 plus x squared. So why don't we do that? Okay, this is my algebra skills I'm thinking of. If this was not trig functions, if it was just letters, could I handle it? Of course you can. So let's do the same thing here. Okay, so I'm factoring it out because I have these 2 terms separated by an addition and this 1 term. And they both have what I want, which is the secant square of beta. So I'm factoring it out, the secant square of beta, and I'm going to put the leftover inside of a parenthesis. The secant square of beta divided by the secant square of beta, that's 1. Plus, when I divided these 2 terms, tangent square of beta times secant square of beta divided by the secant square of beta, we just get the tangent square of beta. Okay, good. We'd use algebra. Now what? Right? So I immediately see this over here and say, that is a substitution I can do. I can also substitute this. I'm going to leave it alone as the secant square of beta. But now this can be substituted by the secant square of beta. And look at that. Totally, I see the end of the end of this problem right away. Okay, this 2 multiplied is like if you had x squared times x squared. Okay, what is it? It's x to the 4th power, right? So this 2 together is nothing but the secant to the 4th power of beta, which is exactly what we have on the right-hand side. Okay, so what was really, really ugly and complicated and long, all we did was use a little bit of algebra and substitution, and bam, we got it done. Okay, So guys, all of these problems requires a little bit of algebra, a little bit of substitution, fractions, you know, adding common denominators. So you need a little bit of your algebra skills and to simplify it and substitute. So for your homework, I already did 2 of your problems. I'm assigning, it's going to be classwork. Hopefully if you use your time wisely, you're going to be doing it in class to the best you can. Work with a partner, and then you're going to go to questions 1 through 12. I already did 2 of them, which was 6 and 10. So you only have 10 problems to solve in class to the best of your ability, okay? You try to take as many steps as you can to simplify it. Even if you get stuck at a certain part, at least take a few steps to solve it, all right? Good luck and have a nice, wonderful break.